A particle is projected with speed 7 meters per second at an angle of elevation of 30 degrees from a point O and moves freely under gravity. The horizontal and vertically upwards displacements of the particle from O at any subsequent time t seconds are x meters and y meters respectively. Express x and y in terms of t and hence find the equation of the trajectory of the particle. Here is the initial speed and break down it so we get a horizontal and a vertical component. This is adjacent of angle, so it's cosine. This is the same, these are the same, and it's opposite of the angle, so we can, this is 7 times sine 30 degrees. First we will calculate x. It's a uniform motion. Its formula, the distance is equal to velocity times time, so x is equal to ux times t. It's 7 times cosine 30 degrees times t. This is our first equation. Now we calculate y. It's a free fall. Acceleration is minus 9.8 meters per second squared, and initial speed 7.7 times sine 30 degrees. This is our formula we should use. We substitute these values, so we get this second formula, second equation. And from the first equation we express t from here, and we substitute this to the second equation. Here we write this expression here, so we get this equation. We can simplify with 7. Sine over cosine, it's tangent. Tangent 30 degrees, it's square root of 3 over 3. We can simplify 4.9. Here we get 1, here 10. Cosine 30 degrees is equal to square root of 3 over 2, and this is 3 over 4, it's 0.75, so 10 times 0.75, it's 7.5, and we get this equation. This is the equation of trajectory. Calculate the values of x when y is equal to 0.6. Before we get this equation, now y is equal to 0.6, we substitute this here and we get a quadratic equation, and after calculation we get the 2x. Find the direction of motion of the particle when y is equal to 0.6 and the particle is rising. Here is the trajectory. We know that y is equal to 0.6 and x2 is equal to 1.73. We calculated it before. We have to direction this point. Here it's rising, and we should for this theta we need Vx and Vy. Vx is equal to ux, initial speed, because this is a uniform motion in this direction. It's 6.06. Now we calculate Vy. This is a free fall. We will use this formula: acceleration, initial speed. This was the initial speed. It's 3.5, and s is equal to y 0.6, and we need this quantity. We can substitute these values here, and we get this equation, and after calculation we get V sub y is equal to 0.7 meters per second. And tangent theta, this side and this side is equal. So tangent theta, opposite over adjacent, so V sub y over V sub x. After substitute and calculation, we get theta is equal to 6.59 degrees to horizontal.